Now the question that I'm discussing right now has more than one option correct. Now in these kind of questions, more than one option is correct. It is very necessary and important to check all the choices. Now it is given that A is equal to 1, 0, 0, 1. Now first choice that is given is that we have to prove or we have to check that A minus n is equal to 1, 0, minus n and 1, this matrix. Now how will I proceed? What I can do is this A to the power minus n can be written as A inverse whole to the power n. Now I will calculate A inverse. Now my A inverse will become, first I will calculate the adjoint. My adjoint A will become 1, 0, minus 1 and 1. Now the value of determinant A is equal to 1. Therefore my inverse becomes 1, 0, minus 1 and 1. So this is my inverse. Now let me analyze the value of A inverse whole square. This will be simply 1, 0, minus 1, 1 into 1, 0, minus 1 and 1. This will come out to be 1, 0, minus 2 and 1. Similarly, if we analyze A inverse whole cube and so on by induction, my A inverse whole to the power n will be 1, 0, minus n and 1. That means my option A is correct. Now from here I can proceed. If this is true, that means now I have the value of A to the power minus n. So choice B says we have to find the value of limit 1 by n tends to infinity of A to the power minus n. Now this means that limit 1 by n tends to infinity, matrix, we have the value of A to the power minus n. This is 1, 0, minus n and 1. Now I can multiply this 1 by n inside the matrix. Any element taken outside, when gets multiplied inside the matrix, it is multiplied to all elements. Now limit n tends to infinity. This will be 1 by n, 0 by n, minus n by n will become minus 1, or I will write it for you, minus n by n and 1. Now if I put the limit, what will be 1 by n tends to infinity? This limit will always tend to be 0. So the value of this limit is 0. So my value becomes of limit A to the power minus n, limit 1 by n tends to infinity becomes, on putting the values, 1 by n becomes 0, 0 by n is of course 0, this becomes minus 1 and again 1 by n form, so that is also 0. So my option B is also correct. Now let me check the third option. Third option says limit n tends to infinity 1 by n square a raised to power minus n. Now let me check that part also. This will be limit 1 by n square n tends to infinity a to the power minus 1 minus n will be minus n 1. This 1 by n square will get multiplied. Let me multiply it. This will be 1 by n square. This will be 0 only. Minus n by n square will give me minus 1 by n, and this will give me 1 by n square. If I apply limit n tends to infinity in all these expressions, my determinant will be reduced to, matrix will be reduced to 0, 0, 0 and 0, as all the elements, because of n tends to infinity, will approach to 0, so it becomes, the matrix becomes 0, 0, 0, 0. So option C is also correct. Therefore, we don't need to check fourth choice because it says the fourth choice is none of these. Now, let us have a look at next question. This question involves a series. Series summation is required. Arithmetic progression formula we will be using. The value of matrix AR is given as R, R minus 1, R minus 1 and R. It says that we have to find the value of determinant A1 plus determinant A2 plus determinant A3 so on up till determinant A2006. Now let us proceed. First we will calculate the value of determinant A1. In order to calculate the value of determinant A1, we will put R equal to 1. So the determinant will become 1, 0, 0, 1. And this is my matrix. So the determinant will become, the value will be 1. Now let me check for A2. My A2 matrix will become 2, 1, 1, 2. Therefore determinant A2, the value comes out to be 3. Now let me calculate matrix A3. A3 will become 3, 2, 2, 3. So determinant A3 will be equal to 5. So what I can see is I am getting a series 1 plus 3 plus 5, determinant A1 plus determinant A2 plus determinant A3, so on. This is certainly an arithmetic progression with first term as A, common difference D equals to 2, number of terms as it is already given in the question is 2006. I will apply the formula n by 2, 2A plus n minus 1 times D. Now let me put the values. By putting the values, this will be 2006 by 2 into 2 plus 2005 into 2. Now if I take 2 common from the numerator, I will be left with 2006 into 2006, or I can say 2006 whole square. So this question, sometimes they do form a question which involves a series also, and so we have calculated the answer. The answer comes out to be 2006 whole square. The next question that I am discussing is based on the characteristic equation and is similar to the question that came in IIT, that a matrix was given and we had calculated about 4-5 sessions back the value of C and D. Let us look at this question. In this a matrix is given and a relation A inverse equals to PA square plus QA plus RI is given. Now, if I multiply this equation, both sides by A, I will be left with I. This will be PAQ plus QA square plus RA. Now, I know that whenever I have to find the value of unknown, it is better that I can use the method of characteristic equation. We know that every square matrix, a characteristic equation A minus lambda I is always equal to 0. Therefore, first let me construct the matrix. My matrix will become 1 minus lambda, 0, 2, 0, 2 minus lambda, 1, 2, 0, 3 minus lambda. Now I know that for characteristic equation A minus determinant A minus lambda I is always equal to 0. Let me calculate the value of this determinant. The value of this determinant will become 1 minus lambda into 2 minus lambda into 3 minus lambda plus 2 into minus 2 into 2 minus lambda. Now this should be equal to 0 as by the characteristic equation relation. Let me take 2 minus lambda as common. If I take 2 minus lambda as common, I will be left with lambda square minus 4 lambda minus 1 equal to 0. I will expand this. On expanding, this will become minus lambda cube plus 6 lambda square minus 7 lambda minus 2 equal to 0. Now, this is the second relation that I have derived. Now, let me just simplify this. If I express this, if I take a negative sign common, I can write this as lambda cube minus 6 lambda square plus 7 lambda equal to minus 2. Now this becomes equal to minus 2, of course, that plus 2, and on going on the right hand side it becomes minus 2. So this is my first relation. Now let's go back to the first relation. The first relation is PA cube plus QA square plus RA equals to I. If I simply multiply this by minus 2 on both the sides, I will get minus 2p a cube minus 2q a square minus 2ra equals to minus 2. Now I can compare the two equations simply by replacing lambda equal to a. So my first equation will again become a cube minus 6a square and so on. A cube minus 6a square plus 7a equal to minus 2. Now let me compare the two equations. From here I get the value of minus 2p equals to 1 and minus 2q equals to minus 6 and minus 2r equals to 7. Now if I calculate, value of p will come out to be minus half, value of q will be equal to 3, and my r will become minus 7 by 2. So based on the characteristic equation, we have solved this question, and this question is similar to the question that came in the IIT, in which we had calculated the value of C and D. So this question was of match the following, as you can see in the image, and you can match the options. So students, these were few advanced questions that I have taken in matrices, and most important thing, let me conclude, is system of equations. And then yes, a lot of practice needs to be done on calculating the value of determinants. Sometimes there are few results, if you can remember them, it is very useful because the same kind of determinant is repeated in the entrance examinations, and it helps us to speed up the question to solve it in the best possible time. Thank you so much.